Once the last individual of a species is dead, it's gone for good, lost to history, surviving only in memory. Or at least, that used to be the case. As science has advanced over the years, we've developed potential ways to do the impossible, and extinction may no longer necessarily be the end of a species. It's a fascinating concept that could have massive implications on conservation, so today we're going to be taking a deep dive into de-extinction, covering the methods, some of the potential targets, and of course a complex debate on whether this should even be a topic of debate. But we're getting ahead of ourselves. Before we stop to think if we should, let's get preoccupied with whether or not we could. There are a few processes by which we can artificially bring about the process of de-extinction, but the first, and easily the oldest method, is selective breeding. Backbreeding is the practice of selectively breeding animals for their ancestral traits, for example breeding domestic cattle to more closely resemble the extinct aurochs that they are descended from. The process is time-consuming but simple, and several projects over the past century or so have popped up to try and bring species back. The German brothers Heinz and Lutz Heck were some of the first to make attempts at de-extinction using this method, resulting in the Heck cattle breed in an attempt to bring back the aurochs, and the Heck horse breed in an attempt to bring back the tarpan. Neither of these breeds can really be claimed to be even remotely close to real de-extinctions, but the methodology still lives on today, for example in the quagga project. The quagga was a subspecies of the plain zebra endemic to South Africa that went extinct in 1883 under intensive hunting pressure from humans. And as you can probably guess, the aim of this project is to essentially breed this subspecies back from the dead. They hope to achieve this by selectively breeding Burchell zebra, another subspecies of the plain zebra, for the unique markings and colorations of the quagga. The big problem with this method is that while you could breed back these physical characteristics, the resulting animal will be genetically different from the extinct species, and because the quagga was so poorly studied while it was still extant, all we really know is what it looked like. Without any less visible characteristics to aim for, like behaviour or food preference, many argue we can't really consider any result of the project as a true de-extinction. That's why the project now refers to their animals as Rau quaggas, to differentiate from the originals while paying tribute to the man who first spearheaded the project. However, this is also very similar to how a natural de-extinction event occurred, via the process of iterative evolution. The Aldabra rail was a flightless subspecies of the white-throated rail endemic to Aldabra, a coral atoll in the Seychelles. Around 136,000 years ago, the entire atoll was submerged under rising sea levels, so naturally the rail went extinct alongside everything else endemic to Aldabra that couldn't fly or swim away. But when the island re-emerged around 18,000 years later, the white-throated rail recolonized it. Because there were no predators on the atoll and rails are ground nesting, the birds here had no real need to fly, and so over time developed thicker bones and heavier bodies until the rails on Aldabra were flightless once again. The fossil record shows that this current species is near identical to the extinct one, having evolved from the same ancestral bird and developing the same traits. You can fairly safely call this a natural de-extinction event, although there is some room for debate for both this and any results from selective breeding. However, this depends on how you define a species, and that is a surprisingly complex topic for another day. The second method, and arguably the most well known, is cloning. This is done by taking a cell from an extinct animal, extracting the nucleus, and transplanting it into an egg cell from a closely related species. This related species can then act as a surrogate to carry the cloned animal to term. This is the process that was used for the first, and so far only, artificial de-extinction. The Pyrenean Ibex was one of 4 subspecies of the Iberian Ibex that went extinct in the year 2000, in large part due to centuries of intensive hunting pressure. In 1999, the last individual, a female named Celia, was captured by scientists who took a tissue sample from her ear and released her back into the wild, where she lived for another year, before reportedly being crushed to death by a falling tree, which is certainly one way to go extinct. Efforts to clone the subspecies began soon after, with hundreds of attempts, until eventually, in 2003, one successfully made it to term, and the Pyrenean Ibex lived once more. But this de-extinction didn't last long, as the ibex was born with a lung defect and only survived for 7 minutes. But it still marked a historic moment of a very temporary de-extinction, giving the Pyrenean Ibex the very unfortunate title of the only known species to go extinct twice. We haven't given up on this species yet though, and there will likely be another attempt somewhere down the line. So who knows, maybe this could be the first species to have a hat-trick of extinctions. The biggest problem with this method is that you need intact cells from the extinct animal to be able to clone it, and the extinct species will need a close living relative to act as an egg donor. In the case of the Pyrenean Ibex, we only have cells available from the female of the subspecies, so any cloning attempts could only result in female ibex. For a self-sustaining population to exist again, you would need to create a male of the species using another method, such as by crossbreeding the cloned females with another subspecies of the Iberian Ibex until, over generations, you have an almost entirely Pyrenean Ibex male. But another option for this, and our third option for de-extinction in general, is genome editing. It's also by far the most complicated, and I'm worried enough about how long this video will be, so maybe we'll get into the specifics of it and the role it can play in conservation sometime in the future. In the meantime, here's the complete Wikipedia page on genome editing. The gist of it is that by altering the genome of cells of a living species, you can create cells of a related extinct species. This method opens up far more species as potential candidates for de-extinction, as unlike cloning, you don't need preserved cells for this to work. As long as you have any tissue from the extinct species, you can sequence its genome, although the process of assembling it does get more difficult depending on how degraded the tissue is, so there are limitations to this. One species that's targeted for de-extinction using this method is the Thylacine, or Tasmanian tiger. Despite countless rumoured sightings that still persist to this day, the last known Thylacine died in captivity in 1936, and it remains one of the most well-known faces of human-caused extinction. Since 1999, there have been several projects aiming to resurrect the Thylacine, using either cloning or genome editing. While nothing has come from the earlier cloning attempts, the University of Melbourne is one of the institutions currently leading the way on bringing this species back using genome editing. But even beyond the how, this is a whole lot more complicated than just bringing back whatever is gone, and there is a mountain of concerns, both ecological and ethical in nature. Of course, ethical concerns are hard to tackle since we'll all have different viewpoints on this front. Some may argue that this comes far too close to playing God, even outside of a religious meaning, while others may feel we have an ethical obligation to restore any species that's become extinct through human actions. And others still just want Jurassic Park, as if those movies weren't a very clear warning about this exact thing. Another common argument is that even if it's possible, there should be an expiry date on this sort of thing, so no bringing back dinosaurs but more recent extinct species such as the Thylacine or Pyrenean Ibex are fair game. A problem there is, once again, everyone will have their own opinion on exactly what arbitrary point in time that expiry date should be. Some may think that the mammoth is way too far back in history, while others may think that we may as well try and bring back a T-Rex if we can. There's a further worry that the possibility of bringing a species back will cause a bit of complacency. At the moment, extinction represents a finality, and so a species being listed as critically endangered often results in a big drive to protect and preserve that species. Well, maybe I should say occasionally rather than often, it depends on how conventionally cute or interesting it is. But if we know that we can just hit the undo button, will people care a lot less? In a world where you can grow your own pet dodo, would there be a prevailing opinion that we don't need to care about saving a species because we'll just restore them if they're important enough? We simply wouldn't know what the general reaction would be until it happened, so maybe we've gotten too far into the hypothetical here. As important as those ethical concerns are, you could debate back and forth for days on end about it and probably still not change any minds. So instead, I want to pay more attention to the ecological concerns that are a lot less grey in nature. And why not start with an ecological concern that's also largely ethical to completely discredit what I just said about these being simpler? We live in a world where you need money to do things, and it's pretty safe to say that something as complicated as a de-extinction project would likely need a lot of it. But many argue this money would be better spent on conservation efforts to prevent these species from going extinct in the first place, which is a very convenient segue into talking about what we do. But instead of broadly plugging our membership, I want to bring up one of our lesser known projects that's a personal favourite of mine. Of all recorded animal extinctions since the year 1500, 40% of them have been land or freshwater snails, and given how rare snail conservation projects are, you can almost guarantee you won't see any of them popping up as de-extinction candidates. But on the island of Deserta Grande in the Madeira archipelago, we've been working to prevent the extinction of 4 critically endangered endemic snail species. After more than 100 years without a confirmed observation having been decimated by invasives, these 4 species were rediscovered by local conservationists from IFCN, but with estimates of the wild populations going as low as under 50 individuals, immediate action was clearly necessary. Over several expeditions, we were successful in collecting enough snails to start a breeding program for all 4 species, which has been going well, and the first reintroductions are planned to happen this year. The cost of the immediate intervention to save these 4 species was actually pretty cheap when compared to the numbers we're talking about to bring back 1, and as we're a grassroots organisation that's 100% funded by our membership, we're completely reliant on people like you to undertake projects like this. But even if you're not able to support us financially, I highly encourage you to take a look through our projects over at mossy.earth and to take a look at the accompanying content on our main channel, because if you've made it this far, you'll probably find that interesting too. Oh, and we do have more globally appealing projects than the snail ones. I just like snails and was given the creative freedom to talk about them. But back on topic. An important question you need to answer before reintroducing a locally extinct species is if the ecosystem will benefit from its return, and that question would also be of crucial importance for bringing back a completely extinct species. Take aurochs for instance, the wild ancestors of domestic cattle I mentioned earlier that have been the subject of several de-extinction attempts. In many ways, they are the perfect candidate. They're fairly recently extinct, went extinct due to human actions, and crucially would fill a missing role as a keystone species in many ecosystems. Many rewilding projects across Europe have replaced the aurochs' role with other grazers, like some of the more wild cattle breeds or European bison, but the aurochs could very easily slot back into place all across Europe if we were to bring it back. Then take another well-known recently extinct species, the great auk. This one again fills a couple of common ethical requirements, as it was hunted to extinction by humans in the mid-1800s, so many would argue this penguin-like bird deserves another chance at life, probably also in part because it looks like a penguin and everyone loves penguins. But while its resurrection likely wouldn't cause any harm, there also isn't much evidence it would do any particular good either, as it did not fill a keystone role in its ecosystems. While you could easily make an argument for reintroducing a locally extinct species under this criteria, bringing this completely extinct species back would be far more costly, and you could argue it would be a big waste of money when there are countless struggling extant species. There is of course a third answer to this main ecological question, and that's that bringing a species back would cause more harm than good. Take for instance the megalodon. I don't think I need to explain myself here. The world is constantly changing, and there simply isn't a place for many extinct species anymore. The ecosystems that they once inhabited may no longer be able to support them, or they may not even still exist. While we often talk about extinction as a result of human actions, it is also a completely natural phenomenon. So when it comes to bringing back a species that was lost for instance due to a natural disaster or a combination of human and natural circumstances, well then you're back in ethical concern territory. But there's something missing from this video that you may be noticing, because you can't make a video on this topic without talking about the example that constantly hits the news. The long extinct species that's become the poster child for de-extinction, the woolly mammoth. Mammoth remains have been found in such good condition frozen deep in permafrost that the possibility of sequencing its DNA is very real, and modern day elephants would likely be suitable surrogates. But despite the huge drive, interest and funding behind these projects, it's of course been a very heavily debated topic. Mammoths did fill a unique ecological niche as a mega herbivore, clearing trees and maintaining the mammoth steppe ecosystem. But outside of some tiny remnants, these ecosystems have been gone for a long time and replaced with tundra forests, so some argue there's simply no place for mammoths anymore. The main argument to the contrary of this is that the Arctic tundra ecosystem is very ecologically poor when compared to the mammoth steppes that used to dominate these lands, and that the steppes would have remained their natural state if mammoths and other large herbivores persisted. By bringing mammoths back, it is argued that they can restore the steppes and resume acting out a keystone role in maintaining them. The vast majority of mammoths died off in the late Pleistocene around 13,000 years ago, but a few small populations did survive for much longer, with radiocarbon dating suggesting that mammoths persisted as recently as 4,000 years ago in remote areas like Wrangel Island in Russia. While the reason for their extinction in these final remote locations is uncertain, these are generally accepted as evidence that hunting rather than climate change was more to blame for the end of the mammoths. So outside of the more general questions on de-extinction, mammoths seem to get the green light. And if you're wondering where we're going to fit giant hairy elephants into our modern world, there have been suggestions that they could be reintroduced to Pleistocene Park in Russia, a long-running project aimed at artificially recreating the mammoth steppe ecosystem. They also pass in what is easily the most important category. They've captured the imaginations of people all across the planet. So that means plenty of funding for projects that have been making significant progress in recent years. Barring some drastic bans or legislations, it seems inevitable that these projects will continue to gain momentum, and if it proves to be possible, we'll see some or maybe even all of these species walking the earth once more. For better or for worse, it will certainly make things interesting. Thanks for watching, I hope you enjoyed this video, and I hope to see you next time. Cheers.